Welcome back, my honors trigonometry students. This is lesson 51, common logs and natural logs. Just need a quick reminder that common logs are with the log base 10, and natural logs are written ln, and they have a base e. You're going to need your calculator for this lesson as we do calculate logs and natural logs. I'm going to look at the first practice question A. And it asks us to write 3.6 as a power with a base of 10. So what I'd like you to do is write that as a log with a base 10, and we need to figure out what 3.6 value is. So in my calculator, I am going to find log, type in 3.6, and hit equals. You'll know that you have the correct answer if you get something similar to me. I got 0.55, and let's just round that at 6. Okay, so we use a calculator just to find that decimal value. Now it's asking us to rewrite that as a power of 10. So how I will write that is 3.6 is approximately 10 raised to the 0.556. So my answer is the 10 raised to the 0.556. Okay, similar question here for question B. We're going to find 3.6 as a power when the base is e. When we have a base e, we're working with the natural log, ln, and it has a base e unless otherwise identified. So on your calculator, you're going to find natural log, type in 3.6 equals, and you should get a decimal approximately 1.281. Then when I go back to rewrite that, 3.6 is equal to approximately e raised to the 1.281. So my solution is this part over here, e raised to 1.281. Here's a nice easy one for question C, find log 2.6. Just type it in your calculator, type in log 2.6, and you should get a decimal equivalent similar to 0.415. Okay, so that's just my solution on that one. D, just practicing that you know how to use your natural log key on your calculator. So go ahead and type in natural log 2.6 and see if you get a decimal that is similar to 0.956. All right, and if I'm going too fast, you can always pause, try this out on your calculator, come back. Question E, write 12,000 as a power with a base of 10. So we're going to start this off. Since log has a base 10, we'll write log 10, 12,000. Type that in your calculator, log of 12,000. You should get a decimal, approximately 4.079. So how do I answer this? Well, 12,000 is the base 10 raised to 4.079. That's an estimate, but that's what it's looking for. Okay, and then one more time we do 12,000, but we're doing with a base of e. So for this one, we're using our natural log that has a base e, and we're typing in 12,000. Type that in your calculator. You should get something close to 9.393. So that means 12,000 is equal to e raised to that number, 9.393. That is the solution we're looking for. All right, then when you go over to your homework side, we're going to do question 8 and 9. Question 8 has two parts to it, and let's make sure you're on the right page. I'm on page 347 in your textbook. 347, question 8, part A. You need to calculate log 3.5. So on your calculator, type in log 3.5. You're going to find that Saxon likes to take this out 3 or 4 decimals. Most math classes are going to ask you to take it out 4 decimal places. So there it is, 4 decimal places and then rounded. Okay. All you're doing is typing that in your calculator. Part B of that same question is to find the natural log of 3.5. So make sure you use the natural log key on your calculator. Type that in, take it out 4 decimal places. Looks like it's about 1.2528. So there's my solution. All right, not too bad. Let's go over to number 9. Write 3,600 as a power whose base is e. Since it's base e, I'm going to be using natural log, and I plug in the number that they are asking for, which was 3,600. So on the calculator, natural log 3,600, that comes to 8.189. Okay, so let me rewrite this in an exponent form. It is e raised to the 8.189. And that is my solution for number 8. All right. I think we will go ahead and try one more question together just to make sure you guys are on the right track. I'm going to do question 11. All right, so question 11, taking this from your book, 2 plus square root 3 cosecant theta equals 0. And we need to find all theta that is between 0 and 360. Up to this point, that domain that they give us really hasn't mattered. You'll find later in the week that it is something we have to pay attention to. So I'm going to subtract 2 to the other side as my first step. Subtract 2, so now I have a negative 2 over on the right side. Then I need to divide the root 3 over. So I have cosecant of theta equals negative 2 over root 3. Don't rationalize that yet. We're dealing with an inverse function. You should recognize that cosecant is actually a reciprocal function for sine. So let me rewrite this as sine theta and then flip my fraction. The negative still stays out front, but my fraction flips to square root 3 over 2. Okay, then you need to consult your trig circle, your unit circle, and find when is sine a negative. Well, that's going to be down in quadrants 3 and 4. And then what are the degree values for when it is root 3 over 2? And I think I have 2 solutions for that. Okay, so theta is going to equal 240 degrees, and theta is also going to equal 300 degrees. Just looking at my unit circle to figure out when is sine a value of negative root 3 over 2. All right, so that's it for that one. You have 3 more questions on your own. Good luck.